For months, the distant spacecraft Voyager 1 was silent, not quiet, not fading gently with age. Silent. A silence deeper than mechanical failure, deeper than loss, deeper than anything engineers had prepared themselves to interpret. It was the kind of silence that felt almost personal, the kind that settles heavily over those who have waited a lifetime for a voice that suddenly disappears, leaving only the memory of what once was. For the scientists who had followed Voyager's journey for nearly half a century, that silence felt like the closing of a chapter written before modern computing, before digital communication, before the world itself became constantly connected. Voyager 1 was launched in 1977. At that time, the Internet did not exist in any public form. Smartphones were unimaginable. Even personal computers were experimental machines occupying entire rooms or desks, used only in laboratories and universities. The world was slower, quieter, and in many ways more patient. Calculations were handwritten. Navigation was plotted manually. Space exploration was still an uncertain gamble where every launch carried the possibility of total failure. And yet, from that era emerged a machine designed to leave everything behind. Voyager was not built to stay. It was built to go. Every component was assembled with precision that bordered on ritual. Every wire routed by hand. Every system tested again and again because once the spacecraft left Earth, there would be no repair, no replacement, no second chance. Its onboard computer carried less memory than a modern digital watch. Its processing power would be considered negligible today. And yet it was entrusted with one of humanity's most ambitious journeys, to leave the solar system entirely. At launch, the mission was expected to last only a few years. A brief planetary tour. A collection of images. Then silence. But space does not follow human expectations. Voyager's path was shaped by a rare planetary alignment that occurs only once every 176 years. This alignment allowed the spacecraft to use gravity assists, carefully timed planetary flybys that bend trajectory and amplify speed without using fuel. A technique that turned celestial mechanics into a kind of interplanetary slingshot. Jupiter first. Then Saturn. And for Voyager 2, Uranus and Neptune as well. Voyager 1, however, was placed on a faster trajectory. Its destiny was to reach farther sooner. When it arrived at Jupiter in 1979, the planet revealed itself not as a static sphere of clouds, but as a violent, dynamic system. Storms larger than Earth swirled across its atmosphere. Lightning flashed in unseen depths. Radiation belts surrounded it like invisible storms of energy. Then came Io. A moon that should have been dead. Instead, Voyager revealed it as the most volcanically active body in the solar system. Giant plumes of sulfur erupted from its surface, reaching hundreds of kilometers into space. A world reshaped continuously by internal heat and tidal stress, rewriting assumptions about how moons behave. At Saturn, Voyager uncovered complexity hidden within its rings, thin, intricate structures shaped by gravity and resonance. It revealed Titan's thick atmosphere, rich in organic chemistry, hinting at prebiotic processes occurring far from the Sun. Every encounter expanded the boundaries of imagination. Then the planetary tour ended, but the mission did not. Voyager continued outward. Its destination shifted from planets to something far less defined, the edge of the solar system itself. That boundary is not a wall. It is not a line. It is a transition zone shaped by the solar wind, a stream of charged particles flowing outward from the Sun, forming a vast protective bubble around the entire solar system. This bubble is called the heliosphere. For billions of years, it has shielded Earth from much of the galaxy's radiation, shaping the environment in which life evolved without ever being noticed. The outer boundary of this region is called the heliopause. In 2012, Voyager 1 crossed it. There was no visual change, no dramatic flash. Instead, instruments recorded a sudden shift in particle behavior. Cosmic rays increased sharply. Solar particles dropped away. The sun's influence began to fade. For the first time, a human-made object had entered interstellar space. And what it found was not emptiness. For centuries, space beyond the planets was imagined as a void. A silent vacuum stretching endlessly between stars. Voyager revealed something else entirely. Interstellar space is not empty. It is structured. It is filled with plasma, ionized gas shaped by magnetic fields that stretch across light years. These fields ripple like invisible currents in an ocean. Shockwaves from ancient supernovae travel through it like distant echoes of stellar death. Density changes form layered regions, like atmospheric weather systems on a scale no planet could contain. Voyager moved through this environment like a drifting sensor, mapping a terrain no human instrument had ever touched. Then, after years of steady transmission, something changed. The signal from Voyager 1 began to degrade. Not disappear, but fracture. Telemetry arrived scrambled. Data packets lost order. Numbers no longer formed meaning. The spacecraft had not stopped speaking, but its language had broken. Engineers traced the problem to a corrupted memory chip in the flight data system. Likely damaged by a high-energy cosmic ray, an atomic particle accelerated by distant astrophysical explosions. The very environment Voyager was sent to study had struck back. Repairing it was unlike anything in engineering history. Voyager is nearly 15 billion miles away. A command from Earth takes more than 22 hours to arrive. Another 22 hours is needed for confirmation. Every correction becomes a 2-day conversation with a machine older than many of its operators. There is no room for error. Engineers worked carefully, rerouting functions through backup systems that had remained unused for decades. They rewrote sequences line by line, testing each adjustment in silence that stretched across the solar system. Slowly, the spacecraft responded. And then, after months of uncertainty, the signal stabilized. Voyager was speaking clearly again. But what it transmitted next was even more surprising. Its instruments detected low-frequency oscillations in the interstellar medium. Not sound in the traditional sense. Space has no air for sound waves, but vibrations in plasma and magnetic fields. A kind of electromagnetic hum. A subtle resonance shaped by distant supernova remnants, drifting gas clouds, and galactic magnetic structures. The spacecraft had not entered silence. It had entered a medium that vibrates. Voyager now continues its journey through this unseen landscape, recording variations in density, magnetic alignment, and cosmic radiation. Each measurement reveals that interstellar space behaves less like a void and more like a vast, slow-moving ocean. Far ahead lies the Oort cloud, a distant spherical shell of icy bodies that marks the outermost boundary of the Sun's gravitational influence. Voyager will take tens of thousands of years to pass through it. Long after its power fades, it will continue coasting through that region as a silent artifact of human presence. Its energy source is a radioisotope thermoelectric generator, slowly decaying with time. As power decreases, instruments must be shut down one by one. Eventually, only a faint transmitter will remain. Then even that will fall silent. But Voyager carries something more enduring than its instruments. A golden record. A phonograph disc containing the sounds of earth, wind, thunder, footsteps, laughter, spoken greetings in many languages, and music from different cultures. It is not a message expecting reply. It is a declaration of existence. A fragment of a world placed into the galaxy with no guarantee it will ever be found. And yet Voyager continues onward. Through interstellar space, beyond the influence of the Sun, drifting through regions shaped by ancient stellar explosions and invisible magnetic architecture, it moves as a tiny artifact of intelligence. It may never reach another star. But it will travel for millions of years, long after Earth itself has changed beyond recognition, carrying a silent record of where it came from. In the end, Voyager is not just a spacecraft. It is a boundary marker. A point where humanity extended itself beyond the limits of its own world and into the wider galaxy. And even now, as its signal weakens across unimaginable distance, it continues to send back something remarkable. Proof that it is still going. Still moving. Still listening to the universe that surrounds it.